Hello, everyone. Hope everyone can see me and hear me. My name is Noam. I've been in touch with you for the past month or two regarding your Hackster applications. Hope you're all having fun and progressing in your development. This webinar will include a few things. We will start with a quick overview of what is Walabot and how to set up Walabot. And then we will go to live Q&A. Basically, feel free to ask anything you want. Also, during the presentation that we're going to start with, everyone has, if you don't have any experience or didn't attend any webinars before, so you have like a tab where you can just ask a question anytime, or a chat tab. I'm going to introduce our staff. The one who's going to be walking you through the webinar is Gal, which is one of our R&D members, a programmer, and we will also have on the panel our CTO and co-founder, which his name is Naftali Chayat. And also will be joining us is another member of the R&D, which is the head of R&D, called Adipaz. So yeah, we have a lot of resources here. So I'm just gonna hand it over to Gal. Yeah, have fun.
Okay, hello everyone. My name is Gal. I'm a programmer here at VIAR. What I'm going to do in the next few minutes is going through a presentation about the Walabot, its capabilities. I'm going to introduce some of the applications of our API, which you can use right now. And after that, we're going to take some questions. I'd love to hear all the questions that you've got and answer them. So let's start. So what we're going to do basically is tell you something about what the Walabot is. I'm going to go through very quickly about the setup of the software. It's just basically an installation or two. We're going to go through that. Then I'm going to talk a little bit about our tutorial application, and then we'll get through our API. We'll talk about a simple program flow of the Walabot, about the scan profiles that we provide, and the getters that you can use. So the Walabot, as you know, is a pocket-sized device that provides a cutting-edge technology for radio frequency and images. And as you know, you basically can do three main things with the Walabot right now with the current API, which is object tracking and fall detection. Breathing monitoring, when you can track one or two person breathing, and you can see into and behind walls. Those are the three main things that you can do with the Walabot. I'll just mention right now that you can also, via our API, get the specific signals and the data that the Walabot itself gets without any processing that we are doing in our API. So about the Walabot, about the software setup. So as I believe most of you have already installed the SDK. If not, you're welcome to get to our getting started page and download the installation package and install it. It's a simple installation for Windows and for Linux. I'm going to say this: if you're using Linux or even Raspberry Pi or any kind of a terminal OS that has only terminal, make sure you install it via the terminal. and not via just clicking it if you're using Linux. If you're using Windows, it's the usual way to install any program that you know. So in the SDK, we provide a couple of interfaces for you to program on top. And on Windows, we provide a tutorial application for you to just get started to see what you can do with the API. So I'm going to talk a little bit about the tutorial application. So basically, the main idea of this application is to show you the capabilities of the API. It's divided to 4 sections. 3 of them are like the main one that I guess you already know. It's the people tracking, and the second one is the breathing detection, and the third one is the option to see into walls. The third tab, which I'm guessing most of you didn't quite understand, is capable of displaying the specific signals from 1, 2, or 3, or how many transmitters and receivers antennas that you like, which is also very good if you're gonna program directly and manipulate directly the signals. So the tutorial API is basically just for you to see what exactly the Walabot can do. It shows you the image on some of the sections and the specific targets or pipes that you want to see. Depends on what exactly you want to achieve. All the information that you see on the tutorial application can be derived from our API directly using simple functions that we provide. If you installed our SDK, you can see over at the program files folder where all the all the files were installed. You'll find there a DLL and a H file, everything that you need in order to link it to a C or a C++ project. So basically, we provide the basic C and C++ interface. Besides that, you can also find there a .NET DLL, which you can also link to a .NET application if you'd like to create something like that. And the third interface that we provide is a Python interface. So both of them are available in the installation folder of the Walabot. Depends on where you install the Walabot exactly on your machine. We have a full documentation. It's mainly about the C. It's mainly a C documentation, but you can quite understand logically how it works also in C# or in Python, where you can find all the information you need about all the functions, about how exactly to create a simple new Walabot application, and so on. So let's keep going. Great. So I'm going to talk about the basic program flow of the Walabot. Let's say you are you just got your brand new Walabot, you've installed the SDK, and you want to do something, you want to program it and do something yourself. So what are the what are the basic blocks that you want to achieve during your program? First is the initialization and the connection. After you've imported successfully our SDK, there are simple 2 or 3 functions which you use just to initialize the API and to connect to your Walabot. In some of our interfaces, mainly the Python and the C#, you'll get an error, an exception if the Walabot isn't connected to your machine. So make sure it does. So the basic step is basically to connect. The second step is the main step actually, is where you configure your Walabot. So it depends if you're doing people tracking or if you're into seeing into walls or into breathing. You need to configure the Walabot differently. but the main aspects of it is first to configure the arena of the Walabot. You need to configure the arena. Let's say you're doing tracking. You want to track people in a room and see if someone is full or something like that. So you need to set an arena, basically the size of the room, let's say. So you set up two angles for the Walabot to, let's say, see, and a radius for it, for how far it should see. Besides that, you should configure other parameters like a threshold and filter type for the image to use and stuff like that. That you need to configure before you start the Walabot. After you've done that, you need to start the Walabot. So there's a simple function called start. You use that, and then you can start working with the Walabot sequentially. So on some of the cases, you might want to calibrate. Calibration means that at the first attempts of the Walabot, it records the image, and then it subtracts that image from the beginning from all the other images during the recordings, which means that you won't notice things that are static. Let's say you've put your Walabot in front of a wall, and the wall is static, of course. So it gets the wall on the calibration, and then during the recording and the processing, it subtracts the wall from the image. So you basically won't get the wall as a target per se. So that's the calibration thing. The calibration is one thing that you want to do first thing before you start recording for real. And so from now on, all you can, like, what you should or you want, what I believe you'd want to do is to go into an infinite loop of triggers, which is also one of the basic functions that we provide on the API, and getters. So trigger basically is the function that tells the Walabot to go and transmit and receive some signals. And then you can use whichever getters that you'd like. I'll get to that in a second. Sorry. So that's like the basic flow of a program. You need to initialize the Walabot, you need to set up the configuration, calibrate if needed, start, and just start recording. Okay, let's get going. So what I'm going to talk now is our scan profiles. As I've mentioned before, you need to configure the Walabot before you start using it. The first thing that you want to configure is the scan profile that you want to use. As I've told you, we have three main capabilities of the Walabot, which is the tracking, the see into walls, and the breathing tracker. Those are divided into three different profiles. Let's say you want to see into walls, then you'd like to use the profile short range imaging, the first one that you see. If you want to just do tracking to see people in a room or anything like that, you'd want to use the profile sensor, the middle one. And if you want to track breathing, track a person breathing, then you'd want to use the third one. The main differences between all these profiles are the number of antennas of the transmitters and the receiver that we use to record the image, which is what sets the frame rate of your image and the quality of the image that you provide and that you'll analyze. So each profile is designed to a specific target. Great. So let's say you've programmed your Walabot, you've configured your Walabot to do one of the three things. Let's say you're trying to see into walls. So you've chose the image profile and you've chose a specific arena for it to look at in the wall. And then you've chose, let's say, a threshold, because you know there's the wall is not exactly a uniform wall, so you want to get a sorry. So you want to get a higher threshold, let's say, and then you use the start function, and then you want to start recording and see what you get. So on our API, you can get we provide a couple of interfaces to get one couple of levels of information that you can derive from our API. The most high level one, let's say, is the targets themselves. You can use a function called get imaging targets, and you'll get the specific X, Y, Z, the specific Cartesian coordinates of the targets that you look at inside the wall. You'll see if it's a pipe or if it's something else. You'll see where it is in the wall, and you can use that information to present it or do whatever you like. If I want to get a little bit lower, so and I don't want to. I'm sorry. Okay. So let's say I don't want to get a target. So the next thing that we provide is the raw image. The raw image is one of the middle steps that we in the API are achieving using a couple of processing algorithms. And the image can show you very efficiently, like, what's the state of the thing that you see. Let's say if it can show you very specifically how a pipe is looking in a wall, or how a human being is looking inside the room. So I believe most of you would like to use the raw image and analyze it yourself. If you know any image processing algorithms and stuff like that, that is the place to use it. If you don't want to even use that and you don't want to get any processing that we provide using the API, you can use the raw signals. Using our raw signals function allow you to get the amplitudes and all the information you need, the bare signals that the Walabot records, and then you can analyze whichever way that you want. This is the fastest function. It does almost no processing at all, and those are the main getters that we provide. So okay, so I hope you kind of got a sense of how of what you can do with the Walabot and how you can achieve it. We have a full documentation in our on our site. You can you can see each and every function what you can do. And just a second. And great. So now what we're gonna do is we're gonna go through a live Q&A. I want to hear what you guys have to answer your questions. So
yeah, hey, it's Noam again. Guys, listen, right now you have we would like to answer your questions because I can see that already on the questions thread that some of you already asked some questions. You can, first of all, raise your hand, and second of all, just send a question. We will give you the ability to actually, we will unmute you so everyone can hear, and then we will provide you with some answers. So yeah, so we are waiting for your questions. Hello, Mr. Adarsh Verghese. Am I pronouncing it correctly?
Yeah, you got me. What's up?
All right, yeah, man. What's up?
Yeah, I've just tuned in the webinar. I wouldn't claim that I've been using the Walabot a lot. I just got my hands on it, and I was just wondering how I was trying to develop an application for people tracking. I mean, more of like counting the number of people in the room.
yeah.
And I don't think I can ask you too many deep questions at the moment because I haven't taken a look at the API completely. But from what I've seen so far, you guys use an RF frequency to bounce off people, and it comes back, and you can get like a 3D scan or a 2D scan. And I mean, can you recommend how I should approach my problem with the Walabot?
So,
Yeah.
I don't know if you heard what I've said before. Basically, you just need to experiment a little bit with our tracking application. You just need to set up the Walabot, as I've mentioned before, using the sensor profile
Right.
and set an arena in the size of the room that you want to use,
Mm-hmm.
and that you want to scan and
Right.
just get the
I
output.
I can scan and I can do image processing and count the number of people. I understand. What would the refresh rate be? Like, how many frames can I process a second?
I didn't get it. Sorry. Can you
Uh,
come on?
so I'd be able to process the image using the API and count the number of people in the frame. Is it possible?
Yeah, as I said, you can get the raw image yourself and then and analyze it, of course.
Oh, okay. I understand. How? Okay, okay. No, I got it. I got it. Thanks. I think
Okay.
that. Yeah.
Thank you.
Okay.
Hello, Chris.
Hi, how are you?
Good, and you?
Can you hear me? Good,
Yeah,
good.
can hear.
So for my application, I'm attempting to detect objects moving towards the Walabot at relatively high speed, and preferably at a fairly good distance. So far, with the calibrations I've tried, I've only been able to detect objects within, roughly 5 feet. Is there a calibration change I need to make, or is there a limitation to what the best distance to work with for the Walabot device?
So we can get up till, I believe, 8 meters. Meters, I'm talking, something like that. So I wouldn't recommend Walabot to see more than that.
Okay, so what type of calibration would I use to be able to detect multiple targets at, say, up to 8 meters?
So there aren't types of calibrations. There's only one type of calibration you can use. The main thing I believe you want to do is to place the Walabot static as you can, and just leave the arena empty, and then just calibrate, which means that just to do to call the triggering function enough times for the calibration to complete. And just I believe the main thing that you want to do is to make sure that the arena is totally empty, so that each object that will enter the arena after that will be detected clearly.
Okay, so I think I may have misspoke by using the term calibration. I realize there's one calibration process. I guess more I want to know what are the best setting of parameters in order to set the arena to the largest possible size, and which type of sensor setting you would recommend for that type of application.
Okay, so I'm gonna divide my answer into two answers actually. First is
Okay.
you can use calibration, and if you'd like, you can even use one of our filters that we provide. It's called the MTI filter. Did you had a chance to have you come by it, Bryce? Have you bumped it? Did you
Right,
see
the
it?
MPI filters for multiple targets.
So the MTI filter is not only for multiple targets; it's for distinguish between static and non-static targets. Okay, so let me
Okay.
explain you shortly. Okay, so as I've told before, the calibration, what it does basically, it during the calibration process, it records the image, and then during the real recordings, it just subtracts the image that you've recorded in the calibration. So far, we good?
Yep. Yep.
Okay,
Follow you.
so the second thing that you can do is use I call it MTI mode. What it does basically is you set the filter to MTI. There's a function called set dynamic filter, if I remember correctly, and then what it does basically, basically does what the calibration does, but always, like it always records the last couple of images, and it always subtracts the last couple of images that you already recorded like a couple seconds ago, which means that objects that are like, let's say, static in the environment, if they'll stay static for a couple of frames, then they will get erased from the image because you always subtract them.
Okay, so it only keeps track of moving targets at that point.
Exactly. So that's like the outcome of that. So basically, what I would advise is first try to do a really good calibration, and then try to detect all those objects, and then just to use MTI mode, which is just, as I've told, just call this function and give it one of the variables, and that's it. And then you don't even need to calibrate.
Okay.
Okay.
Yep, that makes sense.
Okay. So it helps you.
So as far as just one other part of the question of, and maybe you could more generically review the setting of the arena. Like, I know there's a number of different parameters that can go into that setting, but
Okay.
I don't have a great idea of the mathematics involved. So if you could give us a quick overview of that, that would be helpful, I think.
So let me just talk a few minutes about the arena settings, specifically about the arena, okay?
Yeah.
So basically, when you do tracking, so you need to set a polar arena, which means you need to set a theta, phi, and r values. So I recommend to set them as much as possible like the size of the room that you're trying to track in, and then and the other thing that I want to talk about is the resolution. Each axis, like the theta axis or the r axis, has a specific resolution. You can specify a resolution for each of these axes. That resolution, you can kind of view it as how pixel will the raw image will be. Okay, so if you set a high resolution, so you get the image very, very pixely, it won't be so accurate, but it will be more faster because the processing will be just faster. And on the other side, if you set a low resolution, the image will get you get a really good sense of like what you see exactly, but the processing will take significantly more amount of and significantly an amount of time that it's a greater amount of time. So it's always like this game when you want to set up the best arena that you can, and you just need to. It's just a matter of trial and error, I guess. Depends on your arena exactly.
Okay.
Okay.
Thank you.
Okay. Thanks, guys. Hello, Jack.
Hi,
Hey, Jack.
Boker Tov.
Good morning.
Asking about what's the best way to identify a specific person. In other words, if I want to make sure I always get that person and I don't get it mixed up with another person, what unique characteristics would you suggest?
So that's actually a great question. We are tracking the same question right here at Vire, basically. So the best thing that I recommend right now is to work directly with the raw image. Say is to get the image and derive from that and see all these blobs that are like targets, analyze them in a way, in some way, and get a sense if it's a human being or not. This is the basic recommendation.
You don't have any specific ideas of, like through breathing or some other way to make sure you identify that person?
Well, the main problem is that a person can look very differently on the image. Depends of like where the Walabot is, in his environment. If the man is standing or sitting, in what exactly is he looking at the Walabot? Is his body is vertical to the Walabot? Is horizontal to the Walabot? It can be very. It has a lot of states. You know, you can't just. I can't just tell you, okay, if we'll get this and this and this image, then it's a person.
So,
You need to be a little more
if I
specific
know,
than that.
if I know for sure that that person is standing, there is a person standing, 4 meters away or 5 meters away. I want,
Yeah.
and he's going to stand up, and he's going to walk towards the Walabot. So the question is, is there, and if I know exactly, if I put him in the same location each time, can I tell if it's the same person?
So, let me get it straight. You wanna know if it's the same person always,
Yes.
or if it's a different person? You wanna.
I want to make
What's the
sure
question?
I identify the person so that not somebody else is going to be walking towards the Walabot. Yeah. I want to make sure it is that same person that I'm monitoring.
Just 1 second. Okay, just a second. Hey Josh, I'd like to transfer this question to Naftali, our CTO, so just a second.
Okay. Can you please repeat the questions?
So if I put a person in a specific location, I mark up the wall and I put him against the wall and he starts walking towards me, I want to make sure that I'm monitoring that same person each time, that it's not a different person that's walking towards me. So as I do multiple, weekly scans of that person, I want to make sure it's the same person I'm seeing.
Yes. So basically, if you have just one person, it's a non-issue. But if you have multiple persons, you can experience situations in which, for example, people cross each other and the tracker experiences difficulty telling whether it's two persons who just came towards each other and then went back, or whether they crossed each other. So certainly there is a challenge of telling who is who and building appropriately the tracks. So that's one of the reasons that the API that we currently supply can address a limited number of targets, and of course we'll be glad if you can within your application try and improve on that.
Okay, thank you.
Are you online? Did you hear my answer?
Yes, thank you.
Hello?
Yes. Sorry, I heard the answer. Thank you. Are you not receiving me?
Yeah, great, Jack. Thank you. Hey, Mark, do you copy? Mark? Hello, Mark? Hello, Marcel.
Hello. Good afternoon.
Good afternoon to you. So, how can I help you?
Yeah, I have a question. I can detect targets up to 3, and I can measure the distance between the Walabot and the target. But how can I measure the width of that detected target? So how big the target is? Right now, I'm doing a sweep of different measurements with one degree of line of the Walabot, and I'm increasing that degree 90 degrees, so I have different measurements, but that takes a lot of time. Is there a quicker way to detect the height and the width of the target?
So let me just repeat it. You said you wanna detect the depth of a target or the width, or can you go again?
The width.
Okay, so and what's your okay, I got it. Just a second. Okay, great, Marcel. I'm gonna pass that also to Naftali. So just 1 second.
Okay.
Yes. Yes. Can you please repeat the question? I apologize. Yes.
Okay, I want to measure the width and the height of a detected target. I can measure the depth of it, but the width and the height of it, I cannot.
Yes. So the width and the height depends on the angular resolution of the sensor, and while the depth resolution is several centimeters, sometimes less, the angular resolution is on the order of, I would say, 10 degrees or so. So as the target gets away, it becomes difficult to measure its exact size.
Okay, the target is standing still.
Well, if it is standing still, again, if you've calibrated your system, you can now see the impact of that target relative to the situation that was before this target entered the arena. But still, your ability to measure its size depends on whether the target is large enough relative to the angular resolution of the system.
Okay,
And
in my project, it is about 1 meter away, and the target is about 30 centimeters. So it's resolution quite okay.
Yeah, so I would say it's a bit marginal in terms of telling its size. You probably can't tell whether it's much smaller than 30 or about 30 or more, but the angular resolution is much coarser than the distance resolution.
Okay.
Thank you.
Thanks.
Hi. My mic is
עכשיו. Sorry, we had a little bit of a technical
Hello?
problem here. So let's get going. Anjali? Hello, Anjali?
Hi, good morning.
Good morning.
Hello, can you hear me?
Yeah, we're hearing you
Hello?
well.
Oh, sorry about that. Having some sound issues. So I have a couple of questions. First of all, I'm working on the Mac OS,
Okay.
and I didn't see any documentation about that on the website, and I think my question was answered in the presentation that you don't offer a Mac-compatible SDK. Is that correct?
Yeah, that's true. We do not offer that. What you can do is you can use the VMware or any type of a VMware software to install the SDK.
Okay, so before that, I actually tried using Mac ports because using the Linux version, but I can't seem to get that to work. So do you have anyone on your team with experience with that, or would I definitely have to use, VMware or some kind of virtual machine?
I'm actually not familiar with Mac ports. Is that any kind of a VMware program or something like that?
No, but it basically gives Linux programs compatibility in Mac. I've used it for some other programs as well.
Okay, so I imagine it won't work for you. I imagine it won't work for you, and the only way is to use VMware.
Okay. And secondly, so I haven't actually started working with the device yet because of this, but is there a way to actually save the raw feed? So extract it from the device and then save it locally on my computer, or can I only see it on the interface on the app?
Oh, okay, that's a good question. So we provide functions to get the raw images or the signals that we're recording. And from then on, you can create your own application, which just saves it in any kind of format that you'd like. We do not provide our like self applications for that.
Yeah, right, of course. All right, thank you.
Thank you.
Hello?
Okay, and we're hearing now Feza.
Hi, how are you?
Hey, good, and you?
Good, thanks. So I have a few questions about the raw signals.
Yes.
And so you mentioned that it's actually measuring the reflected power, am I right, of the object that it's detecting? Okay, so what are the units for this power that it's measuring? Is it like in milliwatts? What are the units for that the amplitude that's doing?
That's a great question. For that question also, let me pass it to Naftali. So just a second.
Okay.
Okay, hello Fazan. The raw signals are, I would say, in arbitrary units. It's difficult to attach to them maybe specific physical meaning, and you need to maybe calibrate your system and learn how to relate the specific amplitudes to reflectivity or object size. It's not currently related to specific physical parameters.
Oh, okay. Can you suggest a way how I can actually do that? How I would go about, just to give me a general idea of how I can relate it to physical parameters, excuse me?
Okay. For example, you can put your Walabot against, for example, a metal wall at 1 meter away and look what is the amplitude of the reflection that you get. Okay, so that will give you an idea of how much power could you get from an object, or put some reference object, for example, some metallic object of size that you know, so that you can learn to correlate amplitudes to specific reflection values.
Oh, okay. Awesome, thank you.
Pleasure.
Hello, George.
Hi, can you hear me now?
Hey, George. Yeah, we can hear you.
Okay, so I have a couple of questions. First, how much power is transmitted when you say you have, for example, two antenna pairs or one antenna pair? How much power is actually transmitted, and what's the maximum power transmitted when you have all antenna pairs activated?
Great. Just a second. Just a second.
Okay, Gal, let me take this one. Okay, so basically, Walabot operates according to ultra-wideband regulations, which means that it transmits less than 1 milliwatt of power. Now, this is not related to how many antennas are used, because we are transmitting from one antenna at a time. So whenever any given antenna transmits, it transmits less than 1 milliwatt. And if you use more antenna, basically it will mean that the scan will take more time, but in terms of the power transmitted, it remains the same.
Oh, okay, that's good. I have another question. It's on the tracking. So, is there any limit on how many objects can track simultaneously?
Okay, so that relates to the question we had before. When you have many objects, it becomes more complicated to differentiate which reflection belongs to which object, and currently the API is limited to up to 3 objects, and you can try and write your own tracker, which maybe in some situations will perform better, but it is certainly a challenge.
Oh, okay. Thank you.
Hello to Gary. Gary, can you hear me? Okay, guys, I can't see any more questions so right now. So let me just get Noam the voice.
Hey guys, it's Noam again. So basically, we're seeing that you don't have any more questions. So I hope that anything that you wanted to know, you got your answer. Right now, I want to give the opportunity to all of our Hackster contenders to tell us if they want to tell us, you know, something about maybe the way, the progress that is made with this application, or any future ideas, or anything and all that you can think of. Just raise your hand, and we would love to hear it. So take like a few seconds. Oh, and suggestions on how to, let's say, on the API. What would you like to have on the API? Some questions I'm interested to ask you is, do most of you develop for Linux, develop for Windows? Some of you, maybe you want to develop for Android. This kind of stuff. Are you doing it for as a research? Are you doing it to actually have like a product at the end of it? Is it just a hobby? Anything like that, we would love to hear. So I'm going to give you like a few minutes, And oh, okay, we got Marcel here. Hey Marcel, what's up? So we have here a bit of a okay. All right.
Hello?
Yeah, now I can hear you.
Okay. I'm developing on Windows, everything in C#. I've made a Windows application because to calibrate the Walabot, I had difficulty with that. So I made a Windows application where I can easily adjust the parameters and apply that directly to my application. So I basically recreated the Walabot tutorial API tutorial application, which helped me a lot. So I really recommend people to
All right.
adjust every value from the data file and the distance. I had some trouble finding out what the best profile was, and the best resolution was for each. So I'm still working on that.
I'm sorry, Marcel, I didn't get it. You had some problems with what exactly? Can you repeat it?
What the profiles really were and what the best profile is for each scenario.
Oh.
And what the difference that makes in that application.
Wait, have we cleared it right here? I mean,
yeah, this webinar was clear in that sense.
Great.
All right. I mean, if there's anything else you want to know or which is unclear, but if you can try to be specific as to which profile you try to use, go ahead and do that, and we will try to answer that as well.
Currently not.
Oh, all right.
Yeah, okay.
All right, cool. Thank you very much.
Thanks.
Okay, we got Elvis. So Elvis, I'll be unmuting you. So yeah. Hey, Elvis.
So my first thing is a question about the support. I was wondering if you guys could, in the Hackster Slack group, work with them to create a channel for the Walabot, just so in the future, if we have any other questions, or we want to share our projects with each other, we'd be able to do that.
That's a fantastic idea. Yeah, that's a great idea. We are also planning on doing on our website on walabot.com, having like a community section, a community page. We are basically waiting for more guys for more of you to actually submit the project with the code. So then we can actually display it on our site. But yeah, that's a great suggestion to open like a channel on Slack for that. Yeah.
Okay. My other question was, as far as viability, right now what I'm working on is, with the NVIDIA Jetson, trying to get it set up with the Walabot, to use a neural network to be able to improve the calibration, so that essentially you could aim it at your object or whatever, and it could get a detailed profile of that through the learning algorithm, and then use that to do future recognition. But I haven't actually worked with the sensor much, so does it give unique enough data to be able to do that, or would that really not be viable?
Alice, well, it sounds great, basically, I'd say, using neural networks. I believe the Walabot does have enough information for you to put it to the neural network system. I think you should work directly with the signals that the API, that the Walabot provide.
Uh-huh.
Okay.
Thank you.
Do you have any more questions, maybe?
Not right now.
Okay, thank you.
All right, guys, so if no one has any further questions, it's been a pleasure. Sorry if there were a bit of audio technicalities. It is our first webinar, so excuse us. Yeah, so this has been fun, and we'll definitely consider the last suggestion by Elvis to create a channel on Slack where you can just share your projects. That's definitely something that we want. And yeah, let's see your projects come to life. Thanks a lot, and goodbye.